So we've learned that waves transfer energy from one place to another through oscillations. So the particles are actually not having any net movement in the direction of the wave or in the direction of the energy transfer. They're just oscillating around a fixed position. But how do we know this? What's the evidence? Let's start with the example of waves in water. So here we've got a rubber duck that's floating in the water, so it can't swim or anything like that. And let's say there's a wave going toward the left. Let's see what happens to the rubber duck. Okay, so you can see it's just oscillating up and down while the energy from the wave is going towards the left. Okay, so this shows us that the objects that are floating in water, and probably the water particles themselves, are oscillating without actually moving. There's no net movement, there's no overall movement in the direction of the wave. So the particles are just transferring energy from one to another without moving. It doesn't have to be an object floating. So in this example here, I've got some dye that I've added to the water. So it just shows the water particles in a certain area. And watch what happens as the wave travels. Okay, so the dye is just oscillating up and down. And maybe it diffuses a bit, maybe it spreads out a bit, but there's actually no overall movement towards the left because the particles of water and the dye itself, which is inside the water, is just oscillating, transferring energy from towards the left, but without actually moving itself. Okay, so we just looked at waves in water. What about sound? Okay, so if we hit this drum here, it's going to make sound waves that's going to travel towards the right. And we know it's caused by the air particles oscillating around a fixed position. But how do we know this? How do we know it's not the net movement all the way from the left towards the right? Let's say it is the net movement. Okay, let's see what happens. So all those particles, let's say they're all moving towards the right and they move, transfer the energy with them. And we know this is not the case because if they did all move towards the right, then we would have no particles over here. Or we'd say it's low pressure or even complete vacuum. So that means there's no particles there. And if we do this, then actually the rest of the particles in the room will rush into that space and we'll notice that change in pressure. Also, all the particles that move towards the right, well, they would actually push on the listener, so they would feel a force, so they'd feel something that feels almost like a wind pushing past them. And this doesn't happen when sound travels through things, so that's how we know it's not the movement of particles all the way towards the right, and this is not what happens. They just oscillate in the fixed position. Another example is if we have smoke like this, and then we make a sound wave. Here I've shown sound wave as some wave fronts. Okay, basically just a line that joins all the peaks. And it goes through the smoke without moving the smoke from the middle of the room here. So you can hear the sound through smoke without actually having the smoke particles reach you. Same with walls or solid walls. So the sound can go through solid walls and the wall particles in the wall won't move all the way towards you. So that's how we know it's just the particles oscillating and transferring energy from one to another without actually moving all the way to the listener. So far we've seen that waves in water and sound waves do not transfer particles from one place to another. They just transfer energy. But what about light and other electromagnetic waves like infrared and so on? So an example of these traveling without transferring particles is the radiation from the sun. So we can see the visible light and the infrared heat from the sun and other kind of electromagnetic radiation that reach all to us in Earth all the way from the sun through empty vacuum, so no particles in it. So they travel as electromagnetic waves, or in short, you can call it EM waves. And this is made from electric field and the magnetic field oscillating. So it doesn't actually have any particles or transfer any particles at all. It doesn't even need particles.